everyone. In this video we will discuss Poisson distribution. So imagine you're a shop owner and you want to predict the number of customers arriving in the next hour, and the Poisson distribution is really useful in this case. So there are certain conditions. So let's take a look at the conditions. So basically the Poisson distribution models the number of events that will occur within a fixed interval of space or time. So let's take a look at the conditions, and then we will take a look at some examples. So first, the events must be independent. So this means that in the case of customers, like one customer coming to the shop does not influence other customers. And the second, the events occur at a fixed rate. So this means that the mean or expectation is constant. So in Pulse paper there is some question like they state that the mean changes. So if the mean changes, this implies that Poisson distribution is not useful, is not appropriate. But this is very important. This is very important. Another conditions is that what I've mentioned earlier, that the events occur in fixed length of space or time. So let's take a look at some examples. So for example, let's take a look. For example, the number of admissions each day in a hospital. So this one is related to time. Another one, which is related to space, can be the number of floors in clothes. So in 1 meter square of cloth, for example. Now let's take a look at an example. So suppose X follows a Poisson distribution with mean 1.5. So this is the model. The model for Poisson distribution is as follows. So it follows X follows Poisson distribution lambda, where lambda is the fixed or constant mean or expectation. So suppose X follows a Poisson distribution with mean 1.5, where X represents the number of plane crashes, involving loss of lives per year. So this is fixed in time. suppose we need to find the probability that the number of plane crashes involving loss of lives in 1 year for it to be less than 2. So, number of plane crashes involving loss of lives in a particular year to be less than 2, we can find the probability. So, first we need to be able to find probability x equal to 2, suppose. So exactly 2 plane crashes occur. We can model it as, so the formula is given as probability x equal to a is equal to e minus lambda multiplied by lambda power a over a factorial. So this is equal to e power minus 2 multiplied by 2 power 2 over 2 factorial p x equal to 1 is equal to e power minus 2 because lambda so I'm sorry, this is e power minus 1.5, this is 1.5, and this is 1.5 as well. The mean is 1.5, lambda is 1.5 multiplied by 1.5 power 1 over 1 factorial p x equal to 0 is equal to e power minus 1.5 multiplied by 1.5 power 0 over 0 factorial. But to simplify this, we can write it as follows. We can take the e power minus lambda common, so e power minus 1.5 and then we put 1.5, so we need to find 0, 1, 2 here, less than or equal to 2. So 1.5 power 0 over 0 factorial plus 1.5 power 1 over 1 factorial plus 1.5 squared over 2 factorial, and this is equal to 0.809. So this is a simple explanation of the Poisson distribution. It is just an introduction. So to recap, we have some conditions that need to be followed, and the most important one is that the events should occur at a fixed rate and the events must be independent. And we have some examples, and then you should be able to evaluate when it is like is equal to something or in a range, the probability. Now suppose another thing is that suppose we want to find a probability that exactly 4 crashes occur in 2 years, so in a 2-year period. So now for one year lambda is equal to 1.5, so for 2 years lambda will be equal to 1.5 times 2, and this is known as scaling up. So this is important as well, which is equal to 3, and then px equal to 4, we substitute in this formula here, which is very important. So this is equal to e power minus lambda, which is 3, lambda is 3, multiplied by 3 power 4 over 4 factorial, which is equal to 0.109. 168. Now suppose we want to find number of plane crashes that result in loss of lives in half year, and then now the mean would be 1.5 over 2, and this is known as scaling down. So this is it for introduction to the Poisson distribution, and in the next video we'll take a look at more advanced concepts regarding Poisson distribution. Thank you for watching.